In this video, we're going to take a look at what are called uniform motion problems. These problems are ones where we have the certain train leaves and when do the trains meet, or when is it that they are a certain distance apart. Kind of a classic math problem that people make stereotypes about. And so let's figure out how we can deal with problems like this. So this first one right here, it says two cyclists, one averaging 11 miles per hour and the other 29 miles per hour, start in the same town at the same time. If they travel in opposite directions, after how long will they be 232 miles apart? Okay, maybe that gives you some flashbacks to problems that you've heard before. But let's figure out how we can deal with this. First of all, uniform motion problems often deal with the distance formula. Remember, the distance equals rate times time. And if we use this to help organize our information, that can really set us off to a good path to figure out what's going on with these. So we've got two cyclists. So let's just go ahead and start setting up our distance equals rate times time. All right, so we've got our first cyclist and our second one. One is averaging 11 miles per hour. That's the rate. So we're going to put that one here. And then the other is averaging 29 miles per hour. So 29 right here. Now, they're starting at the same time, and we want to know when they are 232 miles apart. Well, we're asked to find after how long. So the time is what we're interested in finding. So let's go ahead and call that X. And they're both traveling for the same amount of time. So let's call them both X. Then to get the distance, remember, we're just going to multiply those two things. Rate times time. So 11X is the distance that will be traveled in X amount of time by the bike going 11 miles per hour. And then 29x is the distance that will be traveled by the bike that's going 29 miles per hour in X hours. Okay, now, what do we know about those two distances? They need to add up to this, okay? Because the first one, 11 miles an hour. Each hour, they're traveling 11 miles. So like in 3 hours, they travel 33 miles and so on. So these two distances, if we add them up, need to total 232 miles. So 11x plus 29x is equal to 232 miles. We can handle that, right? Combine like terms, so we end up with 40x, and that's equal to 232. Then we divide by 40 on both sides, and we end up with x equals 5.8. Well, what does that mean? Well, what does x stand for? Let's go back here. X is our amount of time. So it's 5.8 hours that they will be 232 miles apart. Now, if you want to check this, what we could do is just take that 5.8 and put it in for x in both of these. So 11 times that and 29 times that, and then add those two together, and that should give us 232. I did that. It works. If you want to double check me, feel free to do so. That's how we can check our answers. Okay. The second one, we've got two trains. An express train and a local train leave Grand Junction to travel to Pleasant Valley. The express train can make the trip in 4 hours, and the local train takes 5 hours for the trip. The speed of the express train is 12 miles per hour faster than the speed of the local train. Find the speed of both trains. Okay, so again, we're dealing with that distance formula. Distance equals rate times time. I'm going to change colors here so we can kind of keep track. All right, so again, we're going to start out, let's just lay out our information in this distance equals rate times time format. We've got our two trains. Let's call them ET for express train, and we'll call it LT for local train. Okay, so what information do we have? Well, it says the express train can make the trip in 4 hours. 4 hours is the amount of time, so that's going to go right here. Then it says the local train takes 5 hours. Okay, so our amount of time right there, 5 hours. What else do we know? The speed of the express train is 12 miles per hour faster than the speed of the local train. Well, I don't know the exact speed of either one, but it says 12 miles per hour faster. And that's what the problem is asking me to find. So let's call the local train that speed X, and that means the express train is 12 miles per hour faster. So that's going to be X plus 12. Okay, so then remember distance equals rate times time. So if I multiply these, that will get me the distance. So let's do that. We have 4 times x plus 12. That's the distance for the express train. And then we have 5 times x is the distance for the local train. Now, what's the only other thing? We have to write an equation somehow. Well, what do we know is equal in this case? Well, it says that both trains go from Grand Junction to Pleasant Valley. So that means the distance that they're traveling is the same. So that means our equation that we can set up is going to be 4 times x plus 12. This is the distance traveled by the express train, okay, in 4 hours. That's how far it's going to go. And that distance is going to be the same as the distance traveled, remember, rate times time, by the local train. So that's 5x. Two distances, they're equal because they're going from the same place to the same other place. And so we distribute first of all, so we get 4x plus 48 equals 5x, and then subtract 4x, get all those x's together, and we end up with 48 equals x. Ooh, so what's that mean? Well, what was x? Remember how important it is to label and set up what exactly these variables stand for. If we go back to our original problem, right here was the x. That is the rate or the speed of the local train. So the local train, LT, is traveling at 48 miles per hour. Then the express train, well, do we have something in terms of x? Yep, right here. Now we know that x is 48, and the express train is going 12 miles per hour faster. So 48 plus 12 gets us 60 miles per hour. And again, we could check this. We could take 60 miles per hour times 4 hours, that's 240 miles. And 48 miles per hour times 5 hours is also 240 miles. So we also know that there's 240 miles between the two towns. That's kind of cool. Some extra bonus information there. So, uniform motion problems. Deal with the distance formula. Distance equals rate times time. Start by organizing the information you're given using the distance, rate, and time. Remember, rate times time gives us our distance, and then we can use those distances usually to set up an equation. In this one, we knew how far apart they were going to be. In this one, we knew that the distances were the same because we were going between the same two places. Some fun stuff here and some kind of a classic math problems that people will joke about sometimes. I hope this was helpful, I hope the next time you hear a joke about a math problem like this, you can provide some little bit more insight of how they work. They're not so scary at all. Hope this helps, and keep working hard on your math.